Determination of lambda naught of a weak electrolyte. First thing is lambda naught value for weak electrolyte cannot be calculated graphically. So that's why Kohlrausch calculated lambda naught value of weak electrolyte by knowing the limiting molar conductance of the three strong electrolytes containing the ions similar to that of weak electrolyte. Limiting molar conductance of the weak electrolyte is calculated by knowing limiting molar conductance of three strong electrolytes containing the ions similar to that of weak electrolyte. For example, here three strong electrolytes are taken, sodium acetate, HCl, NaCl, to calculate the limiting molar conductance of the acetic acid. Acetic acid is a weak electrolyte. How this formula is considered? First, lambda m naught values of the three strong electrolytes are taken, CH3COONA, and lambda m naught value of NaCl and lambda m naught of HCl. In these three, which is having two common ions? First identify that. NaCl is having two common ions. Na is a common ion with respect to CH3CONA. Cl is a common ion with respect to HCl. So which is having two common ions, that should be subtracted from the lambda m naught values of the CH3CONA and HCl to calculate lambda m naught value of acetic acid. Lambda m naught value of acetic acid is equal to lambda m naught of CH3CONA plus lambda m naught of HCl minus lambda m naught of NaCl. Why we are subtracting? If we split this into ionic form, then we'll get the complete clarity. So we can write that equation as lambda m naught of CH3COOH is equal to lambda naught of the, for here this one, lambda m naught of CH3CONA, that can be written as lambda naught of the CH3CO minus plus lambda naught of the Na plus, ionic conductance of the CH3CO minus and Na plus. Similarly, HCl also we can consider lambda naught of HCl H plus plus lambda naught of the Cl minus. Minus NaCl also we can consider lambda naught of Na plus minus lambda naught of the Cl minus. So here plus lambda naught of Na plus and minus lambda naught of Na plus we can cancel, and Cl minus also we can cancel. What is remaining here? Lambda naught of the CH3COOH is equal to lambda naught of the CH3CO minus plus lambda naught of the H plus. So we are getting the lambda m naught of the acetic acid by using three strong electrolytes, that is CH3CONA, NaCl and HCl, which are having the common ions, similar, containing ions similar to that of the weak electrolytes.